Hello scholars, today we're going to begin our unit about acids and bases. So we talked last class about molarity and dilutions and solutions. So we're going to continue on with unit 6, and this is acids and bases introduction. So please label your notes with today's date and acids and bases. I want to start by asking you, what do you know about acids and bases? When you hear the word acid, what do you think? When you hear the word base, what do you think? Include at least 3 things that come to mind. These could be examples, these could be definitions or properties of what an acid and base might be. Your teacher will be looking at this question to see what you came to class knowing, so make sure to answer this to get full credit on your notes and practice. So the acid properties we're going to talk about today are acids taste sour. You might already know this. They will turn litmus paper red. Litmus paper, your teacher will be showing you in class, but is this paper that if it's an acid, it will turn red if you put a little sample on it, or if you dip the litmus paper in a base, it will turn blue, which we'll talk about in a second. It has a pH of less than 7, and this is what we talk about acidity levels on. Acids and bases can be on a pH scale from 0 to 14, and between 0 and 7 means it's an acid, so that helps us to determine how strong or how weak an acid or a base is. And acids will also react with metals to make hydrogen gas. So here are some pictures of acids. So those right there are all acids. And when we see, like, for example, they react with metal to make hydrogen gas, maybe you've gotten lemon juice on a metal before, or you've seen different things corrode. Maybe you've heard of how, like, Pepsi or different colas can be really corrosive, and sometimes it's kind of alarming to put it in your body, but they could actually break down metals depending on how strong an acid is. And then also acids donate H+ ions, so hydrogen ions, and we will talk more about this in class and in your next video about what does this mean by saying it will donate a proton or donate a hydrogen ion. So those are our acids. What about bases? Well, bases taste bitter. So if you were to taste any base, they would be bitter. So for example, maybe you've tasted tonic water and experienced that before. Hopefully these other cleaners you have not tried, but and I would not recommend it. That would be against the recommendations for them on the back. But they would taste bitter. These would turn litmus paper blue, so I think base blue. Then the pH is greater than 7, so anywhere from 7 to 14. The closer to 14, the more basic it is. They have a slimy texture, so maybe you've noticed this if you've used any of these cleaning supplies before, that they're kind of slimy. And instead of donating hydrogen ions, they will accept hydrogen ions. Make sure you've written down all these properties of bases. Make sure you also have the acid properties written down. If you have not, then you can rewind the video and write those down. What is an acid and what is a base? Well, we have 2 definitions of an acid. An acid, an Arrhenius acid, is one type, and these are H+ ions in solution. So hydrogen ions in solution. And then a Bronsted-Lowry acid is an H+ donor, or a hydrogen donor. So we see here the HCl in this case is our acid because it will donate when we come across this double replacement reaction. It will donate its hydrogen ion to the H2O to make it, or to this one, to the OH. And then a base will then, an Arrhenius base has OH- ions in solution, so that's why we see OH there, or hydroxide. And a Bronsted-Lowry will accept the hydrogen ions. So it wants an additional hydrogen. So we see that over here, the OH becomes accepts the hydrogen from this. So write down these 4 definitions. And again, even if you're a little confused, we'll talk about them more in class. And please write out this equation and label your HCl as your acid and your NaOH as your base. Pause the video if you need to finish writing those down. This is a pH scale, and like we said, pH paper helps us to identify if something's acidic or basic. But we also have a more detailed pH scale, anywhere from 0 to 14 we see here. And a pH scale is used to determine the concentration of hydrogen ions within a solution. So how many H+ ions does a solution have, or how acidic or how basic it is. So completely neutral is 7, so you're going to want to write that down. Neutral is 7. Make sure you write down what a pH scale is as well. And then like we said, something that's 14 is super basic. So it has a high hydrogen ion concentration. That could be something like sodium hydroxide or household bleach, versus something like eggs or milk of magnesia. Those would be pretty basic, or not as basic. Close to neutral, not quite. Detergent, of course, is not as strong as, say, bleach, but still it has basic quantities or characteristics. And then a straight 7 would be pure water. It's completely neutral. And then we start to get things that are more acidic. So milk is slightly acidic, coffee even more acidic. So maybe you've heard, if you're a coffee drinker, or if someone at home drinks coffee, they might say, man, this coffee tastes more acidic than other kinds of coffee. I know certain places have more acidic coffee than others. And then of course like tomato juice, orange juice, stuff like that. Versus hydrochloric acid is super acidic, which is why it can actually be dangerously acidic and can burn you because of how acidic it is. And if you think of someone that maybe says they have like heartburn or acid reflux, that likely happens after they have a lot of acidic drinks or something to eat. So they might have a lot of coffee on top of a pizza that has tomato sauce on it. And all these different things, and maybe the pizza has cheese on it, which is also acidic from the milk. So they have acid reflux. Their body is having a hard time with all that acid that they took in to themselves. Even those are all healthy acids, just in large quantities can kind of mess things up a little bit. So that's your pH scale. And then we see here, we could also use pH paper to help us determine what the actual pH of a sample substance is. So if something turns out completely red after putting pH paper on it, it would mean that it is very acidic. And then we see the different colors. I thought I had pH paper with me, but maybe I don't. And then if something turns purple, it has a pH of 14. And if you ever had to determine the pH of something, I would give you this scale. There are 7 practice questions, so please pause the video and answer these 7 questions. Write them down in your notes. Your teacher will be checking for these practice questions. And if you have any questions, make sure to email your teacher or ask them in class, your next class. Thank you and have a wonderful day.